Hi there, I'm Akshay Pranchpe, AI Project Manager at IconPro, and we'll show you today our software RS for predictive quality and process optimization. I will just show one example, but of course, RS also works for completely different use case with similar data structure. So let's take a look at how can we train a machine learning based model using IconPro RS, deploy it, and use it in production with very minimal effort. So what you're seeing here is a dataset for wire EDM process or wire electric discharge machining. Wire EDM is a precision machining process. A conductive wire is used as electrode to cut through the workpiece. Electric discharge between the wire and the workpiece erodes the material through a series of normal and short circuit discharges. There are various applications for wire EDM process. For example, under aerospace industry, also for tool making and also in medical device manufacturing, etc. So if I take a look at on the left side of this file, this is the data that is being generated during this process, where we see 26 features or the process parameters that can be used as input to the model with one quality parameter, that is the curvature or the geometric curvature error for the part that is being cut in micrometer. These 26 input parameters include features like the raw material, so which kind of wire that is being used, the height of the workpiece, some parameters like the proportion of normal discharge, proportion of short circuit discharge, cutting speed, and some machining parameters which are encrypted here, and some parameters like wire tension, wire speed, and so on. So inside Icon RS, you can see three major things. On top, that is the dataset, the experiment that is being run, and the deployments that are currently being run. With just few clicks, you're able to upload a data. If you click on the upload here, you can either drag and drop a CSV file or click on the button to upload a particular CSV file. Let's provide a suitable name for the dataset. Let's call it EDM demo 1. As soon as the data is uploaded, it goes through a series of validation checks for the dataset. In case some of the validation doesn't meet, then it provides a feedback to the user and he can check with that dataset alternatively. As soon as the data is uploaded, it goes through a series of validation checks for the dataset. For example, the size of the data, number of samples, number of features. IconPro can handle file size as big as 400 megabytes, and number of samples can be anything higher than 100. As soon as the validation is done, we can start with training a model. To train a model, go to the dataset and click on New Experiment. Give a suitable name to the experiment. Call it again Demo 1. And click on the Next. And just with very minimal amount of inputs, you can start training a machine learning based model. On the right side, you see type of these features. And if you think if particular type is incorrect, you can then also cross-check it and change it. For example, here, the height is classified as category since there are only 4 height, but from the process knowledge, this turns out to be a numerical feature. Once this is changed into numerical feature, you see a change in the plots here. So we see a histogram with which we can see the correlation with other process parameter. For example, height is very highly correlated with the amount of energy that is being spent for cutting a particular workpiece part. The next thing that we need to do is select a target parameter. So in this case, we already know that our target parameter is the curvature. So we select this as the curvature as the target parameter. And since this target is a numerical value, as we can see here, this will be classified or trained as a regression model. By clicking next, you move to the configs required for training a model. And the only config that user needs to provide is training time. Let's give it 1 hour. And then just start experiment. And as soon as the experiment is started, you can see progress of the experiment with different steps mentioned here. So let's take a look at an already trained model for this dataset. So what you see here are the different metrics that are being calculated for the test split of the dataset. So R2 score, mean squared error, root mean squared error, and mean absolute error. We see that for this dataset, we have a mean absolute error of 0.8, which is very good for this particular use case. Scroll down, then we see a scatter plot which plots the actual value that is being recorded and the value that is being predicted by the model. The values close to the 45-degree angle states that the prediction is close to optimal or with very less error. If we scroll up, then we see the model information. The overall model that is being trained is not just a single model, but a combination of various models, an ensemble of various models, in order to maximize the possible accuracy. The next important module that we have inside Icon Pro is feature importance. So as we saw, we have different machine learning based models, which might be inherently black box model. In order to get an insight or to interpret this model, we have a module for feature importances. To compute feature importances, just click on compute feature importance with some time limit. Let's give it 30 minutes and you can start an experiment. Let's take a look at an already calculated feature importance plots. So these are the feature importance plots that already been calculated. What you see on the left is the non-directional feature importance, which states that how much importance did a particular feature have in getting the final target value. Whereas the feature importance plot on the right is the directional feature importance plot, which gives you a little bit more insight into the data and the particular predictions that were being made. For example, if you take a look at the height value here, the value for height are color coded from blue to red implying a higher value, whereas blue implying a lower value. What we see here is if the height value is higher, then it has a positive influence for the prediction value, which means that a higher height is more likely to give a higher curvature error, which actually makes sense from process point of view. You can select top 5 or you can also select all the feature and then it shows the feature importance for all the features here. The next important module inside Icon Pro RS is the optimization. Optimization module lets you train a reinforcement learning model to find out the best possible combination of process parameter to get a desired target value. In order to start optimization model, we can click here on add optimization and then it takes to a dialog box with different configuration. So as usual, we need to provide a training time. Let's give it 60 minutes. Then we need to provide optimal value for the target. So target in this case is the curvature value. Of course, we would like to have curvature as low as possible. From the dataset, what we see is 0.7 is the lowest value in the dataset. So we give it as 0.7. From process point of view, curvature value less than 5 micrometer is acceptable. And then we need to, of course, choose which parameters are the control parameter. Not all the process parameters can be control parameter. For example, you cannot change the height of the workbench. In this case, we already know that some of the machining parameters can be controlled. So just clicking those parameters here, wire tension can also be controlled, wire speed or the feeding of the wires can also be controlled, fluid pressure, and then these are the other machining parameters that can be controlled. On the right side, you also see the range of this parameter. So in this range, RL model or the reinforcement model is able to change this value. These are directly taken from the data which was uploaded before. If you want to change this is also possible. Let's take a look at an already trained optimization model. So once the optimization model is trained, you see different metrics. For example, reward, which goes from 0 to 1, 0 implying that the model was not able to find such process parameter, 1 implying that the model was able to find such process parameters in almost all the cases. What's more interesting to see is the distribution of the test split before the optimization and after the optimization. So we can see that before the optimization, these values were spread from 1 to 8 units. We also have values which are higher than 10. And then after optimization, using the optimal values, this distribution shrink towards, towards the direction of value 1. And we can see that the maximum value is less than 5, which is acceptable for the process in consideration. The next important module is the deployment module, which is being used to deploy a model and use it for live predictions. In order to deploy a particularly trained model, just click on the deploy button here on the right side. And with just few clicks, we can take a look at the model that is being deployed. So while the deployment takes place in the background, it goes through different steps like building, out of distribution detection, data preparation, and the final predictor model. Out of distribution detection model is important to find out if the relation between the process parameter and quality parameter is still the same or it has been changed. In manufacturing, it's possible that the correlation changes over time owing to different changes in the process parameter. Let's take a look at an already deployed model. As you can see here, if you want to try this model in production, we can click on try it and it gives you a sample code with which you can already calculate live predictions. We can take a look at the history tab here. Once we click on the history, we see history of different predictions that have been recorded together with the optimization values. We can hover around this and check different optimization results and the prediction results. For example, we click on this particular value. What we see here is the process parameters before the optimization and after optimization, and also the train in the process parameter. We can also take a look at different metrics. For example, for this sample, we had a reward of 0.824. And you can also download these results to use it externally for your purpose. So this is all about how to do a very quick training, feature importance, and optimization model with Icon Pro RS. So go ahead and train your model with Icon Pro RS.